There's a lot of in-depth information about commercial units. You know, obviously it's not a residential. It's we could go for days and days talking about different things, but as we start doing this presentation, I want to uh, do some of the basic things and talk about pre-startups and startups because 90% of the problems that we see are small oversights and things of that nature. So one of the first slides we got right here is inspect the unit and the hidden damages and on-site damages. And if you look at the picture of this unit I've got right here, it actually has the black cardboard protecting the coil up front. And that's one of the things that I've always asked is you could put it back on while you're craning the thing up to the top, but check your coils and make sure that they're good to go. Um, and all that good stuff. If any of the, make sure all your optional accessories are installed. If you have an economizer that's put on from the factory, I would rather you put the hoods on when it's up than instead of when you're lifting it up, because you don't know what it's going to bump into, etc. Before you even hook the crane up, verify you've got correct power and everything else. Blower spins freely, and we'll check refrigerant pressures a couple of times. Obviously, you can't check running pressures because you haven't got it hooked up, but we want to check, make sure there's no dead circuits or anything like that. So we want to make sure when we do that, you don't want to lift it on the roof at that point. So, you know, permanent service cover, gas, if you need LP, if you got your conversion kits, make sure it's the right conversion kits. You want to make sure you have everything set. Now, the last two, if you're already on the roof and they've actually cranked this unit up before you've had a chance or the company's had a chance to come up and make sure everything's all right, well then obviously your rated load amps and everything over here is probably going to be correct. But you need to go back through and make sure all these amperages and everything's correct. So when inspectors and other folks come around, you have the right disconnect boxes and everything else. And if you got any question on these with the minimum and maximum amps, and you'll see with power exhaust, all this other stuff, because that adds to it. And the bigger the unit you get, the more horsepower you're going to have for a power exhaust, and especially depending upon which unit you got. Now, a lot of these things I'm talking about today can be applied to K series, Z series, even your splits. So I tried to make sure I kill as many birds with one stone as I can. But the new filters, you want to make sure they're clean because if they crank these things up and they did a lot of work down into the given space down at the bottom, no telling what it's pulled up there. So we want to make sure, especially when we start getting the static pressures, and make sure that's good and clean. And then all your ducts are cleaned and open. That's a huge deal. So on the next one here, this is the one thing that I show folks. When I say folks, I mean engineers and then project managers. When I've gone out on rooftops, and you'll see the next picture in just a moment as to why um, these clearances are really, really important. We got to make sure that we keep these clearances for airflow and serviceability as well too. Um, some of these units is just they're big, and especially your 20, 25-ton units, you have to keep in mind that your blower section is going to pull out, and it may be 4 or 5 foot wide. So if you don't have enough clearance, you're going to run into some issues, such as this one. I really don't know how this was allowed or put in like that. You can see down here that the curbs was actually put down. There they are. They're sitting on the roof, but you will not get into that. And this is a KGB because there's your exhaust outlet, and it's dumping right into here. Plus the fact you see they still have the cardboard on here. So I hope that coil was inspected. But the local codes is one of the things I want to lean into and make sure everyone understands that sometimes local codes will take precedence over some of the instructions. So if for instance, if the instructions say you have to have 5 feet between these units, but the local code says 8 feet, then we're going to go by 8 feet. It's hard to get an inspector not to do that. And obviously the efficiency and the operation is going to go to you know what, but then the serviceability, you know, these units are expecting to stay on these roads 15, 20 years, 20 plus, and they're going to need servicing on a regular basis. And I put this picture on here to say, believe it or not, there's situations out there where this happens. So, matter of fact, if you look at this unit real close, the control section is what's being covered up. So how they plan on wiring it, I don't have a clue. So this is a good example of a, we shouldn't have done it that way. One of the most overlooked, and because it's so simple, I mean, a lot of times we look at things and the simple things we take for granted, but properly draining these units, putting the right traps in. And I've seen these things where they try to drain 5 or 6 units into one trap, and that one trap can't handle all of it, and it backs up. And when these things are on a rooftop and it does any damage to the inside part of the building, and if it's a department store or if it's in a restaurant or a bar, especially in a bar, when they put a lot of money into fixing up that bar and have it pretty, and then water dumps in on it, it costs a lot of money to repair that. So we want to follow the engineer specs. We want to keep them out of the way. And the one thing here that gets people and that protect from freezing, and you would think, man, it's hot on a roof. Why would I need to worry about protecting it from freezing? Because depending upon what application you're using, this air conditioning can run in freezing temperatures. If it's running in an industrial situation where you have machinery down below and or anything like that may produce steam. So if you're in a dry cleaners or a situation like that, where they have the big iron presses and everything else going, you're going to have high humidity in there. And if you're using single or dual enthalpy controllers and the enthalpy is too high and it's not going to allow for free cooling to happen, then your mechanical cooling is going to come on and you're going to have a way to get rid of that water and protect it from freezing, or you're going to drop water in on that. So that's why it's important to really think about, in residential applications, we don't really care. I mean, we care, but it's not as prevalent. And then tripping hazards. If you like me and you walk up on a roof and you got your mind on things, at some point in time, we all have tripped over a drain line and broken a trap off. If I had $1 for every time I did that, I wouldn't be talking to you today. So make sure they are routed in a good spot to where you're not going to do that. And then make sure you avoid it pulling on the roof, because when the roofers come up and they look for roof leaks, the first thing they're going to blame is going to be this unit. So make sure we route these things to a roof drain or to a proper drain or to where the engineer specified for us to put these drains out. Water damage causes a lot of issues, and it's so simple and easy to avoid. Should it be this way from the factory? No. Does it happen? Absolutely. There's not an OEM who's not going to be exposed to this at one point in time or another. But there's a couple things. Number one, I want to make sure everyone inspects the tubing. We have some distributors that takes these units and inspects them before they go out to the job site. But if everyone will take a good long look at this picture, they'll see that cap tube, and this is actually a pressure switch tube here, a gauge tube here, it's laying up against the discharge line right below the muffler. And you focus on that and you don't see that little piece of copper in the bottom, it'll also make you wonder what happened. Did this unit get reworked? So here's a little bit of a history thing for you here, or a little bit of information, FYI. When you order a unit, if you have to order a unit specifically for an application, what can happen in Stuttgart is they'll have a base unit outside in the storage area. They'll pull it back in and they'll put the accessories on for you. And sometimes things like this will get laid in the bottom and people get in a hurry, they make mistakes, and you'll see stuff like this. That's when you call up tech service, have that catalog number. It's right on the white sticker on the corner post, and we'll find out if they brought it back in and they did anything to it. Secondly, when you did your refrigerant check on the ground before you lifted it up on the roof, if you'd have saw this, this would have been definite putting some gauges on here. And I realize that's time consuming, but think about the repercussions of not doing it. You put a 25-ton unit on the roof and it's got issues, taking that back down and putting it back up is a huge deal. It's not really fun to do on that. So here, we also want to make sure there's no wires touching anything. This happens to be the discharge tube, and you can see this is a unit that was from 2006. So there's been a lot of changes in quality and stuff like that, but this can still happen. I mean, these things are put together by people, so we have to inspect it. And this is a particularly worrisome one right here, because when that wire melts and it shorts out on that discharge tube, we can blow the charge out rapidly, and you're also going to blow a lot of oil out. So not only are you going to lose your refrigerant charge, the chances that compressor going out on you is going to be pretty good. And sometimes in shipping, a lot of things can happen. I mean, they have a test in Stuttgart where they slam some of these units down and testing whenever they develop them. And I've seen that big sled they do it with. And sure enough, sometimes things will shift. And you don't know how they're going to be handled from the time they go from your warehouse to the truck to the job site. Or even if it's direct shipped to the job site, we don't know what it's been through. You or I just don't know that. So it's a good practice to go ahead and look at this as well too. Here's the most probably overlooked, because this control box looks good. Everything's nice and neat, nice and clean, put in there beautifully. All the little wire ties are up and everything's routed, and man, you gotta love it. But I'm going to check the lugs on that contactor, on both contactors, and I'm going to reach in there and I'm going to make sure everything is good and tight. It doesn't take but a few minutes. And again, these pre-inspections are really important, because if those wires are just a little bit loose, it can cause some ghost voltage issues. It can cause, during long run times, all of a sudden, if you got a VFD drive on this and one of these are the blower contactors, well, that VFD drive can kick out on a high amperage and there'd be absolutely nothing wrong with your voltage. The problem lies right here. So while we want to get our mechanical contractors and our technicians that are going out to always pay attention to this, even when they go do cleaning checks, and sometimes these units they get run hard, and they need to check this each and every time, even the plug and play connections. If you'll notice at the very bottom of this box, right down here, there's a plug just laying out. The question comes in all the time, is something missing on the unit? What was that plug for? Why is it like that? These units are pre-wired for a lot of accessories, and you'll see some other wiring issues I want to show you in just a moment. Those wires will be numbered, and you can look and see. If you go to Ally Connect to the home page, go to the bottom of the home page and go to commercial, and then you can search documents, so you can get the service manuals for these and find out what it is. Again, a lot of times these things are pre-wired for a lot of accessories, but you may not use them. So you're going to see random plugs like this that have nothing plugged into it and everything's fine. Once your contractors get used to this, it won't be an issue. Protect your gas valve during startup. Now, I put this one in here. We're going to do a little bit of a startup on gas, but this one here, because if you don't do it in the summertime, if you put these in the summertime, here's the deal with this. If you have multiple units on a rooftop and you go and do your gas pressure check before you even crank the units up and they run the gas lines, and the units are sitting there, if you don't have a gas cock between the unit and the regulator and you put 1 or 2 psi on that gas valve is no longer any good. So we have to make sure, whatever the code's called for, you need to protect the gas valve during that. You'll also hear me say a lot about proper CFM and external static pressure. getting off the right foot by ordering the right drive package, and the unit will deliver CFM. So let's talk about this for a few minutes. We have two different segments. We have the emergency replacement segment where you have a unit sitting in the warehouse and this bar, restaurant, hospital goes down. You take that unit, you throw it on the roof, and we're going to get them up and going. Okay. A lot of times we get into the mindset of, oh crap, we only have 2 hours to get this back up and running, especially in a hospital setting. And I hate to say this, but in a bar setting, those are the two people who panic the most when they don't have air conditioning. And we don't think about what CFM and what static pressure. And next week, I'm going to talk about a little bit more about drive kits, but making sure that static pressure and the correct drive kit in the unit is crucial. And your areas, what customers come to you for the most part. And if you've lived in that area for a long time, what equipment's been on that building, on the buildings that surrounding, and if it was a plan and spec, it's going to be a weird static pressure. So for someone can try to keep their foot in the door to keep replacement units, make sure when you order units and you try to keep some in stock, and this customer is going to have 3,000 units to replace at some point in time, but it's a weird static pressure, go ahead and take the time to order one now that matches that. So when it happens, you'll have one for it. And I realize there's all different kind of tonnages, but that's the kind of forward thinking we need to do to avoid issues. Because when I go into drive kits next week a whole lot heavier, you'll see why. But also this picture right here shows a lot of the inspection. And if you look at the wiring, now this picture was sent to me because I had some damage on the back side of this coil right here, and it was corrected. It was kind of finned down. Everything looks okay now. But my question to the DSR was, okay, these wires right here, did they come from the factory like this, or did someone cut the wire ties loose? The reason I asked that is in this particular unit, both your suction and your liquid line run along the top of the unit right here, and these should be wire tied to that suction line. If it's a heat pump, it's going to be vapor line, but it'll still be insulated, so we don't worry about the wires shorting out like I showed you on the discharge line. My question was to him, did someone take this off? Because when you lean in to check belts, and we'll talk about in a minute, if you loosen this plug up, whatever component it goes to, then we're going to have an issue. And chances are, this is your economizer harness running this way. So when you start having economizer issues and you don't realize when we adjust the belt, you leaned in to do something and your shoulder loosened this up, that's an aggravating service call. So at this point, be very vigilant to look at this and go, this isn't right. I want you to go ahead and wire tie this up. And if you see a lot of these units like this, go ahead and contact Brian Palm and Tech Service and put in a service flash. This is a great one to put a flash in on because it only takes a few moments at the factory to do this and do it correctly. So we may get focused on something else, and it's the proverbial forest for the trees. Now, still speaking along this is a freeze stat that runs down here. And on this, you have one on the coil, and this is in this particular unit. They have another one that's down here. What this does, it should be tied into the wires right here with the motor to keep it nice and neat. Although our pulleys on this side and our feeder tubes from the expansion valves all safe, but if we look right here, that's our main primary limit for the heating section right here. It's well outside of the pulley here, but if that belt breaks, we still are in danger of pulling that off. But we definitely don't want to have a nuisance of pulling all this off. Your cooling will work once you repair it, and you can see this. But you want to neaten these up and make sure everything's nice and neat when you do this. That way you don't worry about it, because you're going to be in this section changing belts and doing things like that. And you want to check the blower rotation on these, okay? And I got another slide coming up here and talk about VAVs in just a minute. But before you start, you want to make sure, not with the compressors right yet, we'll talk about that in just a moment, but it is crucial that we make sure that these blowers are turning correctly to start with. Now, there's a couple of different ways of changing rotation. And then we all know to switch to 2 wires. It's where you switch the two wires at. Okay. So the instructions will tell you do it at the contactor or do it at the power coming in. Okay. So if you do it at the contactor for the blower motor, that's all fine and good. But we need to be very careful of the wiring diagram and where the wires land on that contactor. So if a technician comes up behind another one and doesn't know, and they look at the wiring diagram and see it should be red, blue, yellow, but it's yellow, blue, red on top of that contactor, they go, well, this has a factory problem and it's wired wrong from the factory. That may not be the case. It may just be the wrong rotation. I would suggest, and I realize this is not going to happen too often, to write on this blower rotation corrected and then put something on there if you're going to do it that way. Let's train our contractors to do that, because I've gotten phone calls where we've spent hours tracing down wires and there's absolutely nothing wrong other than the rotation was corrected. And I've kicked my own self in the butt for that one, going, if I'd have thought about it to start with, we could have saved ourselves a lot of time. On the flip side of that, if we have VAV units that have VFD drives in them, well then, and we'll talk about those next week, those correct the rotation for you, but it will not correct the compressors. We have to deal with that in just a few moments as well. So if you have those drives in there, and we use Mitsubishi, but again, we'll talk about the drives next week. They're going to correct it. They got an auto correction in there for that. You still need to check it. That doesn't mean you bypass this step. And I've heard a lot of technicians say, well, I got that VDF down here and it's VFD, excuse me, and it's should correct it, so I'm not going to worry about it. No, go ahead and make the check. Okay. And we're going to confirm that by suction and discharge pressures, but startup sheets are going to help that as well too. So that's the blower section. We're going to make sure it's all cleaned up, all tidied up, but we're going to make sure that that blower, that belt is lined up as well too. So when we do these, there's several different ways of checking static pressures. And I've always said this on this slide, in the real world, it's probably not going to happen this way, but these are the ideal places to check for your static pressure. Now, I get it. Nobody's going to, in not all cases, you're going to be able to do this. There's places on the units, especially on the smaller ones, where you have the two side panels for horizontal discharge. You could put two ports right there and get your pressure reading and stuff of that nature. Make sure we do this and get it right, because next week we're going to go into tacking motors and things like that to find CFMs. And if you have an air balancing company that comes in and does it, you'd probably be well served talking to that company or knowing that company very well to know where they take these readings. If they do not take these readings in the correct spot and there's something in there that can make a difference, that's something you need to know, and you can help them correct it. They may not be heating and cooling specialists. And I would also ask this as well. If they're right there or right above what our total static pressure should be, then if they do it with a dry evaporator coil, when that coil gets wet, it's going to be a little different, and you may need to go in and make sure the changes that are made are correct. So there's all kinds of things, but making sure you're in a good location, making sure you know how they check the static, what the state of the unit was in. I like to check them with wet coils. You get a true, accurate representation. I also like to check them with the filter that you're going to use, okay? If you're going to use a higher MERV filter, don't leave the factory blue filter in there. Set everything up and then put a higher MERV filter in there, because that's going to throw everything else off. So there's a lot of stuff to be considerate here of whenever you're checking these to make sure you're good to go on it. This has always been one that folks get a chuckle out of it with me. You check the belt tension. There's so many different ways to do it. Some people take a nut driver and push down the belt if it doesn't speed up. There's 10 million different ways to check it. There's all kinds of machines out there to check it with. what I'm trying to emphasize here is make sure you do whatever bet that you have. You'll see 10 pounds of pressure on the belt on the center line, 1/64th for every inch. Um, I like to go by the 10 pounds PSI myself. That's me. And look at the deflection. The more you do this, the more you'll know exactly what is and isn't. If you push on that belt and it doesn't move, you got too much. And you're in danger of that spider bracket on that bearing on the blower section. That bearing that's in that spider bracket, it's going to come out. It's going to bearing, that shaft is going to pull through it. And I guarantee you, if you've got a bunch of units on that roof, if you go to another unit, the belt's going to be the same way. You can cause a lot less heartache by going ahead and setting these things up the correct way. Now the instructions are going to tell you go back 24 to 48 hours. I understand that's not feasible for everybody. I understand. But if they are a multiple units on the rooftop and they're going to be there multiple days, I would at least instruct the mechanical contractors, the technicians, say, hey, if you're going to be up there, go ahead and check these out once again after they've had some runtime on it, if you got the opportunity. If you don't, make sure you understand that that belt may loosen up. And if you're already right there where your static pressure should be, and you got dampers and zone systems down below, you could indeed affect that on a brand new unit and not get the desired cooling in the space we're trying to do. So just pushing on the belt can make a lot of difference as well too. Making sure you adjust these. Now I showed this particular example on here because you can pull this one out and you got to loosen up the side bolts, and then you take the two front bolts that are over here and you back this out, but you got to make sure this is even through here, because the next slide I'm going to show you alignment, and if this is out, it's going to throw your alignment out. Now they laughed at me when I worked in the school district because every time I set something, there were Sharpie marks everywhere, because when I got one set up and I got the tension right, and I was the mechanic that had to go back, and we talked about in the previous slide getting that belt tension right. Now, if I had to go back and readjust it, I would put Sharpie marks not only here to know where my plate was, my mounting plate was, but I'd also put Sharpie marks here to where I know how far I rolled that bolt out. And every time I changed the belt out, I would re-put the Sharpie mark right here to know. That caused me a lot less heartache. And that way, when I went to align my belts, I would make sure they're aligned. Now, the belt, the previous slide showed us it's pretty easy to line the belt up. You can look straight in at it. On your bigger units, you're going to have a different blower configuration, and you may have to measure from blower housing to the belt or a known common platform on the backside to make sure you've got the same length from back to front on both ends of that belt. So belt alignment, if it's out of line, your belt's going to wear out quicker, but it can also cause a lot more vibration in the unit. You can check the amp draw as well too. It's going to make your amp draw go up. But we'll talk about that in a few minutes as well. Cooling startup. So we've gotten the unit on the roof. We're doing good. Everything's checked out so far. We're getting our power hooked up. Now we want to fire this unit off. And here's the configuration I talked about with the blower just now. This is a larger unit, so this blower is going to pull out, and then you see the amount of room, because that blower pretty much goes to the end of where your compressors are in here. So you've got a good 4-foot blower section you're going to be able to pull out here. Plus you got your economizer right here that's installed with this one, that if you ever have to pull it out, you're going to need to have that space over here to do it with. So always keep that as well. So back to checking pressures, adjusting phasing, and things of that nature. So you're going to want to check your pressures. You're going to want to make sure your compressors are running the right direction too. For those of us who ever heard a 3-phase scroll compressor run backwards, it is a very distinct noise. You can tell it. For some folks who haven't been in the field as long, and as people we're trying to teach and get them up to speed, they need to look at the gauges. You need to check your gauges anyway, but your pressures will show it as well too. And then we may need to adjust the phasing. And again, make sure somewhere we document that that phasing was adjusted, So if the wires don't line up on the diagram like it was from the factory, the next person who goes and works on it will know. So if you change it on the line side and not the compressor, then you got to be careful of your indoor motor as well too. So you can't forget about that as well. So if you correct the indoor motor and then you go to correct the compressors, go back to the indoor blower motor and make sure, and then you're going to get tired of me saying this, but external static pressure and CFM must be correct. So these next two items coming up, I've given in just about every class ever given. So a lot of the guys have seen this, but this is one of the most important things, and it has saved a lot of people a lot of heartache. Now I've condensed it down to where I'm not going to go through all the live stuff where it pops up the numbers. I got everything on here, and Caroline and I will make available the worksheet. Mark Ham with Famous Supply was gracious enough to build me an Excel spreadsheet that does the calculations for you. Thank you, sir. And I will make sure that's available to everybody, and you plug in the numbers and it automatically changes these for you. But we're going to talk about voltage deviation, and then we're going to talk about amperage deviation and why this is important, because you can't have no more than a 2% out of balance. And this is an example I always give. So we got our voltages here. So we checked L1 to L2, L2 to L3, L1 to L3, and we total that voltage up. Okay, we're going to divide those by 3, and we're going to get the average voltage. So our average voltage for this particular example is 435.6. Now you'll notice, there's one voltage kind of low, and sometimes you'll have a high leg. Now there's all different names for that, some of which I can't say on this because we're recording it, but sometimes you'll have a leg that's got more voltage than the other, and I call it a high leg to be politically correct on here. But then this bottom part of this voltage, you want to subtract your average voltage from what you actually read up top, and you'll notice the middle one, 17.6 voltage deviation. That's going to be a red flag when you see that much come out right off the bat, even before you do the bottom. So you're going to take your average voltage, multiply it by 100, and then you're going to divide that into your maximum voltage deviation. So you'll see the number portion at the bottom. We've got a 4.04% percentage imbalance on this unit. This isn't going to cut it. This is where you and the power company get to have the conversation. And a lot of times where this happens, especially on plants, if they've done addition to any plant, any added any addition, any new machinery, and I'll give you a perfect example. Stuttgart just got that's where these units are produced. They just got new machinery to do some of the panel work and everything else. And they had the people from, one of the machines is from Italy. They had those people come in, do all this machinery, but it pulled different voltages, and they had to put in different power sources for it. So I asked the question, I said, are you going to go back through and check all your voltage deviations? And yes, they had already planned on doing that. In this case, you may have compressors go out, you may have indoor blower motors go out, you may have controls that burn out for absolutely no reason. If you got a KHG on there, heat pump, those microprocessors on those defrost boards can act all kinds of crazy. It can just do weird things for you. But not only to the AC equipment, this is where you go to the building owner, the building manager, the maintenance manager, and say, hey, I've noticed this on here. Are you having any issues with anything else? And the green light may go off with that. I say, yeah, I have been. No one's told me this. So Caroline and I will make this available to everybody, because this is the current imbalance as well too. Now the current imbalance simply means, usually if your voltage is way out of balance, this can be too. But if we go in and start adding accessories when it's on the roof, and we put too much on L1 and L2, you're going to get a current deviation or a current imbalance on that unit, and you can cause issues as well too. So if you look at this particular unit, again, we read L1 to L2, L2 to L3, and L1 to L3. So once you get used to doing this, it's not going to be much of a issue or a problem, but the mechanical contractors need to know this. We total it up, and then we divide by 3, and we got our average current. So our average current is 42.66 on this one. So we put it all in our formula, and you'll notice that only one really sticks out. The very last one, 0.66, but you'll notice on the current, it's a lot more forgiving on the imbalance than the voltage is on the imbalance. So we got a 10% maximum imbalance on this. So the 7.82, we are well within the imbalance. That doesn't mean we can't go ahead and take a look. And if we've loaded up 2 of the legs with single phase stuff, like outdoor fan motors, if this unit's had outdoor fan motors changed out on it quite a bit, you may, and we talk about startups, but if you go on down the road in the lifetime of this unit, and you get a technician that doesn't realize that they have to keep these loads balanced on these 3 legs, they may start blowing fuses for no reason. So keep that in the back of your mind too. We're talking about new startups and getting this thing going, but later on down the road for the troubleshooting purposes, pull this back out and use it again. It's not going to kill anything. If you're like me, you're going to forget, or if you did the startup, I did the startup a long time ago, everything was fine. Always kind of wipe the slate clean and look at it through fresh eyes if you can, and use this. So that's the two of the really important things that's going to help you avoid any issues right off the bat. So we want to make sure we initiate first, second, third stage cooling. The reason for that is if you look and on the side over here, if it's below 60, weigh it in. But the important part for this, initiate the first and second stage cooling, and all compressors and fans should be energized and running to ensure the proper levels. Because, and I put these 2 examples in here, if you look at both of these, the stage 2 evaporators on top, the stage 1's on the bottom. There is no lead lag on these. Okay, this isn't like some of the chillers you may run into or some of the other equipment. So stage 2 is always going to be on the top. So if you happen to be just wanting to check stage 2 and you're not running stage 1 for some reason, that condensate water, number 1, it's not going to flow correctly when it hits the dry part of this coil. It's going to pull off and you're going to have water damage. Number 2, you're going to have airflow issues because the air is going to take the least path of resistance. So it's going to go through this bottom part of the coil much quicker than it will the top. And if you're checking refrigerant pressures, you're not going to get an accurate reading anyway. So you got to make sure both compressors are running. And we also have to make sure someone don't go out there every year and try to change compressor 1 to 2 and 2 to number 1. Because if they do that, you're pretty much going to have a water issue when they do it. So watch out for that as well. But that's why I put these in here so you can see. And in the service manuals, it's got where everything is on here. And then on the cooling startup, you'll see these are constant air volumes. So on the cooling startup, these pressures, circuit 1, circuit 2, do remember that these are checked in a lab situation. So if you've got a kitchen where everything's hot down there and you did a replacement unit, especially an emergency replacement, your pressures are going to be a little bit different than what this chart is. You always want to get these things 24 good hours of running, letting them get into a steady state. Even when you adjust a charge, you need to wait 15 minutes before you even consider the numbers that you're seeing anyway. You want that expansion valve to get settled in, let it start metering and throttling correctly. And then you can go by this, but don't take these numbers all the way to heart, because this is perfect scenario, perfect CFMs, perfect static pressure, and a perfect lab setting. And we all know the world we live in and work in is not that way. But this gets you in the ballpark. This gets you in a range. So I'm just going to take the first 2 numbers at 65 degrees, 104 and 244. So if I'm running 257 on my head pressure, I'm not going to be alarmed. I'm not going to worry about that. Or if I'm running, if it's hot down there, I'm running 115 on my suction pressure, I'm not going to worry about that. Or if it's cool downstairs and I'm running 99 to 101, I'm not going to worry about that either. Okay, that's where we have to understand the variables and a little bit of flexibility on this. Now, having said that, we have high efficiency units that use eco-last coils, or as we like to call them in the field as a mechanic, microchannel. So these are going to be a little bit different as far as microchannels go. We're going to have a charging chart, and you do need to go by this. Okay, this is the one I'll say yes. Go by this. This is the one if it's below or in line, and you'll see over here if the measured liquid temperature is higher than target, add. If it's lower, recover. It does not say let it go in the atmosphere. It says recover. De minimis does not count in this particular instance. And then each one you'll see circuit 1, circuit 2, because the compressors on different units may be a different size. So you may have a 4.5 and then a 5, or vice versa, or something along those lines. So this is the chart I say absolutely yes. Follow it and you'll be right on. Now we want to do the heating startup. That's the cooling startup. And I very rarely do any type of heating. I want to talk about a heating startup, and you want to make sure all these labels. Unfortunately, we live in the world where you got to be careful. You don't want any damage to the building or any damage to anybody themselves, on personal damage to themselves happen. So it's important to know the warning stickers not be taken off. Disclaimer. We use several different valves. Matter of fact, we use 4 different types of valves depending on what unit it is, how big the unit is, whether it's standard, medium, high heat. We need it to be a fast opening valve, a slow opening valve. So these are the 2 Honeywell valves that we use. This first one is the single stage. Nothing fancy, nothing out of the ordinary here. And then we have a 2-stage right here. But you'll see your inlet pressure tap, your manifold pressure, same thing here, because we got to check our pressures. On 2-stage units, you really need to make sure you check high and first stage and second stage, or high fire, low fire, however you want to look at it. And if you have to make an adjustment on either or, I would suggest that you go back and check both of them 2 to 3 times. Because I have found that if you, especially in this, if you have to adjust the high fire, and if you're in a high altitude, especially if you're in Denver at 5,000 feet, this is going to become really important to you. But you want to double check that. And this on the Honeywell valves, these are where you hook your manifold up to, and these are where you make your initial adjustments. Everything should be adjusted from the factory, but that doesn't mean we don't need to check it and then put it on a startup sheet. And these are the White Rogers valves that we use as well. Same thing here. We really want to check and make sure, but we only use White Rogers 2-stage valves. The only single stage valve we use is going to be a Honeywell on here. So you want to check the gas pressure. One of the most important things I can tell you to check is, again, we talked about these units being on the back end of a truck, going down the road, shaking, bumping. You don't know what's going to happen. Let's take a good long look at these burners and make sure they didn't get moved, or just the slightest impingement on that vestibule panel, and you're going to have this flame rollout switch kick out on you. So before we do that, let's always take a look before we start everything up on the heat and make sure none of these burners got moved around during transit. And here's our manifold gas pressures, and these are all in the service manual, and you'll see that's where where you'll check it. And then if you put an LP kit in there, it's going to give you the pressures for that, and then it'll give you a sticker to put on the outside as well too. And then you really want to clock your meter, but let it run 15 minutes, and let's make sure we're getting all the capacity out of it that we can, especially if we're right there, you know, in the northern areas and up in Canada where it gets extremely cold and you have to actually have a heater inside the vest panel area. You really want to make sure you're putting out everything that unit can. It is imperative that we do that. But one of the things I see that's overlooked the most is the temperature rise. And when we check the temperature rise on these units, you got to make sure that your economizers, your fresh air dampers, whether they be manual or motorized, all that's closed. And if you know you're going to run fresh air, or you know you have a minimal amount of fresh air you got to put in there, you got to take that into account for your 30 to 60 degrees rise. So when you have that damper shut and you're right there at a 30-degree rise, you got to think in the back of your mind, well, I've got to have 5 or 10% fresh air. I guess I need to go ahead and get me some more temperature rise out of this. That's where adjusting your fan motor is going to come in handy. Next week, we'll talk a little bit more about that, and that'll clear this up. And then we want to talk about, and this is just an example of one of the standard boards, spark ignition. There's nothing fancy to it, but this is just an example of the lights and the codes that gives you to it. The one thing I want to talk about is the second bullet point, pressure switch proven, but the 30-second pre-purge. As big as some of these units are, it is important to make sure that that pre-purge takes place. You want to get any type of byproduct out of there that may have been lingering in there from the previous cycle, so you don't have any issues or any problems. So for this week, that is what I wanted to run by everybody and get everybody a good initial start. Next week, we're going to talk about a little bit more in depth. I'm going to go into VFD drives, and I'm going to go into a lot deeper on blower selection and blower setup. So today we're going to go over the K-Series Part 2. Last week was kind of important. We went over some things, and I still need to get the voltage and the current balance sheets out there for everybody to work with, because I will reference some of that again today. So what we're going to talk about today is a topic I've talked about a lot, but it's really one of the main things with commercial. So we're going to talk about blower drive packages, and then we're going to talk about determining the CFM and then adjusting the blowers. And then I'm going to talk a little bit about VFD basic, how it works, and some of the troubleshooting. And keep in mind, when I do the VFD here, it's going to be geared more toward our equipment. You can have a really in-depth class on VFD drives and go into all kinds of stuff. But what I've chosen today kind of bounces off of last week into this week, so you'll understand when we put all this together why it's important, some of the things I want to talk about today. So blower adjustments and operations, let's start with that today. So I'll pull this. This is kind of the rule of thumb for factory options here, are the static pressures of what standard, high static, and low static drives are going to be. It's really important to understand where these static pressures fall and what you're doing, because if you're doing a plan and spec, that's all fine and good. You can get the unit, put it on Pro Design and all that, and get everything built around it. But if you're doing a replacement, and understand that if you got a wide open return, a standard drive may not work for you. You may have to go down to a lower static drive or make some changes on your sheaves and pulleys. So it's really important to understand and know what standard, low static, and high static drives are. Usually high static drives are built to order. Those are usually plan and spec, or they're going back into a market where there was another specific brand put on there that had high CFMs. And the reason this is important, if you look, and I pulled this out of the spec sheets, a lot of people go, man, that thing's got over 9 different drive kits in it. And then for special occasions, you got different drive kits above and beyond that. That's why it's important to know your statics, and we'll go over all that. But what I want you to see on this chart, if you look at the RPMs, or the revolutions per minute here, you'll notice there's a fairly decent range. And I'm going to refer back to this in just a few moments when I talk about these ranges, because it needs to be a little bit forgiving in one of the things we're going to do. But this illustrates and shows just how many different kits there are. So you can customize this to just about any application. It has to be a very strange application for it not to work where you want it to. And understanding the blower tables as well, because I'm going to refer back to go look at your blower tables or look at the blower tables. When you talk to the guys in tech service, they're going to look at these same tables whenever we start talking about and troubleshooting and looking at different things. When they say, well, I'm looking at the blower tables, this is exactly what they're looking at. And this part in the yellow is where a standard kit falls in the range. And you look at all these adjustments we can make. Well, those of us who work in commercial and do a lot of commercial understand there is so many applications out there that we have to fine tune and get this machine to work in. And that's why it's so great to have all these settings and everything else. But we always design these units to a dry indoor coil. And that's an industry standard. That's not just an Allied thing. That's an industry standard, because if you go and try to pick out a specific humidity and all this and then test to that, this test standards would be difficult to actually get in there and do. So it's important to understand that when we are in the replacement market and you put a standard unit, but you grab an economizer, well, this chart here that comes out of the instructions and service manual, it gives you a lot of good information. So you look at your air volume by CFM, and you'll notice from 800, this is, 800 to 3,000. The larger the units you get, the more CFMs you're going to have, obviously. But you'll notice a trend that as you get more CFMs and the larger you get, the more pressure drop that these things are going to cause. So not knowing what an indoor wet coil static pressure is going to be, it's going to be really important, because you look here from 36 to 48, 60 to a 72. So that's the range we're looking at. And you can see, again, as the air volume goes up, the CFMs go up, so does this. So does your static pressure and your static drop. Gas with medium input and high input, it makes a difference. If you look here, you've got 0.5 to 0.8, 0.5 to 0.9. There's a lot of difference in these pressures. So when you get a standard unit, do emergency replacement, don't forget to include these pressure drops into your static pressure. And then you can see economizer, that doesn't have very much, but we still have to account for it. So really important that we understand this, and this is where you find out exactly how much a wet coil static drop is going to have. So we're going to determine the CFM, and there's a lot of different ways to do this, and I'm going to show you the RPM way. And I do realize that in some states you can't operate a unit with the blower door off. I understand that, and we'll have to have different methods to do it. This is one of the easiest methods to do, and it's one of the more accurate methods to do as well. So, measurements must be made with a dry indoor coil. So you can do it either way, but if you get the true CFM to start with, you want to do it with a dry coil. Reason being that if you run an air condition and you have multiple compressor circuits and one compressor is not running but another one is, it's going to throw your reading off. So when you get it with the dry coil, then you add that static pressure to it and you know what you got. So you want to run it without a cooling demand. Sounds kind of weird, but yes, you want to run it without a cooling demand. Then we're going to measure the indoor blower shaft RPM. And we're going to leave the filters in place, and we're going to put the access panels back into place as best we can. I've got some pictures to illustrate, and I'll give you a few suggestions on how to do that. And then we're going to do some blower performance based on all this. Now, when we look right here, this is the ideal place to find your total duct static pressure. And granted, I understand that in some applications, it's going to be tough to get to. You may have to have a lift to get up there. There's some other ways around that, but to get a very accurate, if you're really on a job and it's giving you a fit and you have to really be down to brass tacks, we probably need to find a way to do this. Now, I'll show you some alternate methods. I live in the real world too, and I understand that you can't always get to these things, but that's probably one of the better ways to do it. So we're going to pull those charts out. We're going to have that book, and we're going to look at these charts and the installation manuals, and we're going to use the static pressure and the RPM to determine the unit's CFM. And then we're going to apply everything that we just talked about, and then we can make the blower adjustments from that point. And we'll talk about that. I got some really good illustrations. But one of the things that when we do these hands-on classes with this, I had a 10-ton unit, and on that unit, we could take our static pressure right on these doors on the outside. You got to be careful and make sure you don't, if you got an economizer in here, you got to make sure to get on the opposite side of the economizer. In other words, the downhill flow of the air. So you want to make sure you don't run across the economizer. You want to go to the backside, and you can get the readings here, which makes it real simple. In your bigger units, it may be a little bit more difficult. You can put some on roof curves. That's something you'll have to determine when you're out there, if you can or can't. For those of you who's taken my class before, I put little connectors on here, and this is where we took the static pressure. It made it very simple. So we're going to put reflective tape on the blower pulley. One of the most common mistakes that I see is people want to say, well, I'm going to get the blower motor RPM. Well, they put it on the blower motor pulley, and if it's a 1800 or 3400 RPM, that's what you're going to get. So that's one of the things, and trust me, I've done it. When I first did this, I caught myself putting it there too. So we want to go to the blower pulley itself and put it on that pulley. And then we want to energize the blower, and we need to let it reach full speed. That's why I want to talk about VFDs in just a few moments. And I use a laser tachometer to do this with. They're fairly inexpensive, and they're pretty accurate as well too. So there's where we're going to put the reflective tape on there. And most of the times you'll just leave that on there, and you'll know if a unit's been set up correctly or not, or by this method. But that's where you want to get into and do it with. Obviously, power off, all this other good stuff, best practices. We want to make sure everybody's good and safe whenever we do this. But we're going to put that tape there, and then we're going to laser tack that motor, okay? The blower pulley. There's a couple of things here to keep in mind. Number one, let's go back and talk about the RPM range. So when we take the door off the side of this unit, this thing's going to load up with air, and that's going to affect your RPMs. So one of the do this is get the door and cover up as much as the opening as you can, and still get in there to tack the motor. That way, if you're within that RPM range, and I always encourage people to try to get mid-range of that RPM range. That way, when you put the door back on, you won't go over and you won't go under. And I'll show you how to adjust the motor in just a few minutes. But that's one of the best ways to do it here. This motor happens to be sitting straight in. On some of the other ones, it'll be sideways. You'll have to be kind of careful, but still cover as much of that opening as you can, and then go ahead and cover that. Right? If everyone can go on mute, please. All right. So and we've got our RPMs basically with this now. So when we look at the RPMs, we're going to refer back to some charts, but I want to show you exactly what this thing does for us in this next chart. And this is a exercise that we do in the class itself. So we look at this, and we got a 1.4 inch static pressure, and we know our RPMs is 1006. So if we go over and look at this chart, this unit is putting out 4,500 CFMs. That's going to help you out a lot. And granted, I know some people have air balancing companies that come and do all this kind of stuff, but when you have to troubleshoot, or you have to go back and make sure they didn't mess up an adjustment or mess anything up, and so you got a low pressure switch going out because you're not moving enough air, this is going to help you as well too. Generally, you can work with the air balancing company, and the ones I've talked to and showed them this, that they really like this. They go by this method. they'll actually adjust this and then go down. If you got zones, it'll adjust the individual zones as well. But knowing exactly how much you're going to put out, like the 4,500, it means a lot. So then we got to make our adjustment on the pulley. On this, you do have to loosen the set screw and remove the key. And I put this on here, and when I do these classes, I kind of jokingly say you have to remove the key, because I had a phone call where a guy didn't, and it wasn't funny, but it was funny to hear him grunting trying to turn that with the key still in there. So you want to turn it in to increase RPM and turn it out to decrease RPM. But also what we want to be really, really careful of is not to run this pulley or run that belt very low in the pulley. If you have to run the belt too high or too low, that's where we really need to look and say, okay, we may not have the right drive kit in here. And the catalog number I talked about last week, if you'll have that number, it's on a white tag on the corner post of the unit. It'd be like an M199 or something of that nature. And it helps the guys out in tech service, and it speeds them up because they can look up a bill of material, see exactly what kit went in there and what size pulleys is in there. So if you need to go larger or smaller, we don't always recommend that because you have to watch out for wire sizes if you change motors and things of that nature. So getting the kit the closest to what you need is always imperative, but there's always going to be some changes out there. So you got to be careful, because if you run that belt too low into that pulley, and it's adjustable pulley, and it hits the threads on the actual pulley itself, that belt's going to prematurely fail. And you're going to have to keep going back and back. And it's going to be bad, especially we talked about last week, if you got a hospital setting or a restaurant setting and it goes down, it really affects how they operate. So really important not to take this little detail for granted on here, because it means the world to get this right. And then we're going to check the amp draw of the motor. This is extremely critical, especially when we get into the VFD drives in just a moment. It's going to be really important that we check this, and that's where our balance sheets that we worked on last week, and I showed you the examples, that's where this is going to come into play as well too, especially when I start getting into the VFD drives and the percentages that it's going to have to be within to work. It really gets critical at that point. One of the most overlooked things is the little tag that's on the motor itself. It gives you a lot of good information, and I want to focus in on our service factor, SF, right here, of 1.15. And you'll see the full load amps on this tag, 7.8 to 7.4. Just for math purposes, I'm just going to say 7.5. When we set this blower up and we look at these tables and we get our airflow, you do not want to use up that service factor to start with. You don't want to be at 8.5, almost 9 amps whenever you first start this unit brand new. If you have to use the service factor from it brand new, go back and adjust it. Try to stay within your CFM range, but you're going to need that service factor, because if that unit's brand new, the filters are going to get dirty, the coil's going to get dirty, and with age, you're going to build up some pressure. Return ducts and grills are going to get dirty. So if you use this up in the beginning, you're going to ask for trouble a little bit later on, especially when it comes to the VFD drives, and they have the amp check as well and the phase check. That becomes really important. So I always tell people, do not use that service factor to start with. That's there to give you a buffer for wear and tear, not in the front end. So we're going to do a little introduction to VFD today, just talk about a few things on here. Now, you can see Mitsubishi makes ours, and we've had relatively little trouble with them, and they come programmed from Mitsubishi to our factory, and we put them in program. So I'm not going into how to program a VFD today, but we'll talk about why would you need to? Why would you have to get in to something like that. So it's going to synchronize some speeds. The motor's magnetic field rotates it. You got theoretical speeds with no torque and friction. All this stuff has to be taken into account. But the last three bullet points here probably become a little bit more important, because as you drop hertz, you're going to drop RPMs. And the reason this becomes important, because a lot of times you'll have two-stage compressors on these units or 2 or 3 compressors on these units. So you're going to need to adjust your indoor airflow to how many compressors and what capacity you're running this unit to. That's why we're getting the better EERs out of these units. You get rebates back for certain buildings. Well, we had to do all this, and we had to put these drives on there to reach all these new standards. And this is one of the ways, one of the simplest ways you can do it, is just drop the speed of that fan motor. And you'll notice a lot of times the amp draw, especially on your bigger units, it goes down quickly. So how does this thing work? Why did Kyle talk about the amp draws and the voltages last week? Because the VFD, it changes over AC to DC, then it goes from DC to back to kind of an AC. So there's a lot that's going on in here. And this isn't too much different from an actual compressor inverter board. If you kind of look at the 20 series we got and any type of the mini splits like we've got, this is kind of the same sort of technology here, only we're controlling a blower motor to do this. So this is a brief synopsis here of what goes on, and I want to go into it a little bit deeper so we'll understand the importance of how all this works. Now, you've got 6 diodes, and this is just our particular ones, okay? So there's 6 diodes in there, and diodes are like check valves for voltages. So it allows current to only flow in one direction, diodes open and close, and you get pulses. So I'm gonna show you a chart in just a minute that kind of shows you that, but that's why this voltage has to be good and clean going into these units that have this. And capacitors. All right, so DC voltage is not the cleanest voltage in the world sometimes, so it needs to be cleaned up, and that's what the capacitors do. But the capacitors also operate much like a accumulator does in a refrigeration system. It can hold and store some voltages as well too. It's going to absorb the AC ripple, and it's going to deliver a smoother DC voltage. So that AC ripple on DC basically is typically less than 3 volts, but it does have a ripple into there. And the actual voltage is going to depend on the level of the AC feeding the drive as well too. And that kind of makes sense. What you got going in is what you're going to have going out. And voltage imbalance on the power system and the motor load and the impedance of the power system, all that's going to play into factor of how these VFDs work. So you've got diodes that are controlling the power and the flow of the power. Then you've got capacitors in there that are acting as a reservoir and as a filter for the voltage itself. That's why it's important that we keep really within those percentages that we talked about last week. Because this is the wave that we're talking about. Now, after the DC voltage is cleaned up, it arrives at the DC bus on the inverter section, and it's passed through a series of diodes called IGBT. Now, that stands for insulated gate bipolar transistors. Okay, so it's going to have to pass through that, and they act as triggers and send out the DC voltage in short bursts, and then positive. That's why you get these waves, and it actually looks like an AC volt sine wave. But that's what that IGBT is going to do for you, and this is a really good graphic that shows you on there, and you'll notice the timing on the sine wave, how it's going to be affected. So when voltages are really not good, you're going to see this particular wave be affected, and then you may start getting some codes on there, and we don't want to falsely troubleshoot a bad drive and then replace it and put a new drive on there and it does the same thing. It takes a lot to get on the roof and get a unit opened up and work on it. So we definitely want to make sure we don't misdiagnose it. So this is kind of what units we actually use VFDs on. E-Series, K-Series, Z-Series, we use them on a lot, okay? And it's just becoming more of the norm now to see these on units. But you also have a board that helps control this. Now, if we look at the K and the Z series, even the split series, you're going to see this board on there. And all the drives are programmed either from the factory or from Mitsubishi, one of the two, okay? So really and truly, you should not have to go into this Mitsubishi drive and do any kind of changing of the program, which makes it nice so you don't have to sit there and guess. But one of the best things you can do is go on to Mitsubishi's website and download the manual for this, and that way you'll have it. But that's the reason why we install these things, is for 2-speed operation on the fan, power savings, and then there's some on this board. I'm going to show you how to troubleshoot this board in just a few moments. But you may come up with some codes and things of that nature. We have some of the codes in our instruction as it pertains to our programming. That's why I say go ahead to our site plus Mitsubishi's and get the full manual on this. It'll have the full set of codes, and it'll help you in the long run knowing these things, because we're not the only ones that you have. There's a good example of some of the codes there. Stall prevention overload, error inverter reset. I mean, it gives you exactly what's happening with it. And 9 times out of 10, if we set and we get the right blower packages and we set everything up right, we're not going to have very many issues. Whenever I get the phone call that I'm going out on overamperage and this, that, and the other, we go over the basics first, and we usually find out the inverter's doing exactly what it's supposed to do. It's cutting it off because there's a high amperage situation or there's a dirty voltage situation, and it's going to protect that motor. Because when you look at the actual wiring of the motor, it's not all that difficult, but you do have a phase. Here's the numbers. You can only be on 3-phase plus or minus 10% on voltages, up or down. So it's got to be pretty close in. That's why getting our voltage sheets done is important. The frequency has to stay within plus or minus 5%. And you saw we went from about 40 to 60. Depending on what units you have, that may or may not change, but the phase balance is what's important here. If you get the voltage and the current up front, because all you got on the phase balance forgiveness-wise is 2%, and that's it. After 2%, the drive thinks the motor is in danger of burning up or messing up, and it's going to shut it down. And when you wire it, it's fairly simple. You got RST or L1, L2, L3, and then you got the output to the motor. Now, this is already going to take care of the rotation of your motor, and we talked about that last week. You've got to go back and take a look at the compressors, but this will take care of the rotation of the motor because it's programmed in. It knows which way that motor should be turning. So if we got voltage in and we got voltage out, we know we're pretty well good to go, but there's also some other things, that other board in there, so we want to look at. And some of the questions we need to ask is, do we have the supply voltage in there? Well, we just looked at the diagram. It's easy enough to check. Is SD to STF, and I'm going to show you that in just a moment in a diagram. Do we have a signal to run? Do we have 2 to 10 volt DC to run? And that has to come from this board that I'm getting ready to show you. Check all the windings. Everything should own the same. That's our phase 2%. That's going to help too. And that's a really important point, because if a motor's been in there for a while and one of the windings are going bad, it can throw you off. In other words, it can pull pretty close to the amperage it's supposed to be, but yet that phase balance can throw that off. So whenever we get a code like that, make sure we don't forget to on the windings out as well too. And you want to check the motor to ground, and then you can manually bypass the VFD to make the motor run in certain situations. If the VFD is going down or not acting right, you can bypass it until you get it fixed. We don't want to, do that all the time because you take your efficiencies and all that out. But if all these things are good to go, you're probably going to need to replace the drive. But before we replace this drive, let's take a look at the board itself. And there's the STF and SL and SD and all that good stuff. But you want to inspect it for damage. That's kind of a duh. And then you want to call for the blower. And you should get 24 volts between ground and G on here. If we just energize G, so we can go to this board and measure it, and we got 24 volts, we know we're good. We've checked the voltage on the inverter, the high voltage on the inverter, and we'll make sure we're good to go. Now let's check for voltage on the PC and the SD, and we should be 24 volts DC. I was just going to start converting and sending signals to that drive in order to tell it what to run. Because when you get a Y1 and a Y2 call on a multiple system, that voltage, that DC voltage is going to change. Where you saw the 10 volt DC, and it's going to come from these 24 DC outputs on the number 2 header, okay? So we need to check for those voltages there. We got 24 volts in, we got 24 volts DC coming out. We're getting pretty close to saying our board's good to go. But there's also one other check that I would like to do before we say we're good to go. We got this. This is really important piece of paperwork to have right here. This tells you what the board should be putting out at low speed, high speed, illegal state. I love that one. I understand that one. And then blower off. And if you're getting these readings on here and you bypass your VFD drive and your motor works, and we've owned it out, we've done all of our other homework on here, and everything else runs, this tells you whether your drive is bad or whether your board is bad. So the next one you go out to, you'll probably need to go ahead and practice this and look at this. We'll have this presentation out on Allied Air Academy very shortly. And all this stuff that I showed you today is in the instructions and service manuals. And the guys in tech service will be glad to help you if you can't find them and all that good stuff. But with that, for today, if anyone has any questions, please feel free to email me or Caroline or Becca. They're good at technical stuff too. Go and email them. But if you have any questions, please feel free to do that. And please, Caroline, if you want to say this, but remember to log this training in on your portal. It counts, okay? So that was a lot of information to absorb, a lot of numbers. So I didn't go quite as long today as I did last week. But I would like for everyone to take another look at this. And the scripting will be on this as well too. So there's a little bit more facts and figures of where I got this stuff from. But with that, I appreciate everyone's time and everyone's effort, and I hope you have a great weekend. Stay safe.